Hello and welcome to the veterinary animal anatomy brain basically. And today, let's take you to the different route. And what we are discussing in this anatomy basically is the anatomy of different domesticated animals, like the bones, their muscles, their blood circulations. So in this video, I will show you something different, how we can use a very important environmental pollutant in the anatomy for creating something new. And let me show you that basically this is called as ecoplastination. And before going to the ecoplastination in the detail, let me tell you that in the anatomy, usually the students are we have to show the different organs of the animals to the students. And whenever we bring the organs, we usually have to store them in some fixatives or some preservatives, you can call it. And worldwide, are the most important fixative what we use in the labs is the formaldehyde or simply the formalin. But the problem with the formalin is it is very pungent, it is very irritating. And okay, that is okay, somehow we can adjust in that. But continuous exposure to the formalin, it is very carcinogenic. So in front of me you can see this jar. So here it is written as eyes of the sheep. So this jar is full of the formalin, and in this we have put the eyes of the sheep for fixing or for preserving for a long time. And this formaldehyde is considered as a good preservative for preserving the tissues even after 10 years, 14 years, or 15 years, or 20 years. These eyes will be like this. But continuous use of this formalin, because every time the students or even the teachers has to open the lid of this jar, take the eyes out from this jar to show the students, to demonstrate the students, and put it back here. So every time we have to expose ourselves to this formalin. With the result, it is pungent, it is irritating, it is respiratory problems will be there with this formalin, even it is a very carcinogenic. But what will be the alternatives of these? The alternatives are there. Alternatives are there how to preserve the tissues without exposing the students or even the teachers to this formalin. So one of the technique, what you call or what is known as the plastination. And plastination, basically, it was one of the scientists, von Gunther, who discovered a technique, who said that rather than storing, preserving the organs in this formalin, we can preserve to a different way. So this plastination basically involves the use of the different plastic material or resins by which we can use and coat the organs, and we can use for demonstration or for class. So in my hand, if you see, this is the fish, the parts of the fish in the epoxy resin. So this comes, you can order this resin anywhere, and the cost of this resin is almost it goes 400 to 500. So this fish is stored in this 500 amount of rupees we have spent here, and this fish gets preserved here. And rather than storing the formalin, this fish is here in this resin. Again, with this epoxy resin and other resins what we use for the plastination, the problem is it is basically the costly, and it needs some more techniques and more equipments to do these things. Now the Department of Anatomy has come up with some alternative, what you call as ecoplastinates, or ecoplastination is a technique. And here you can see it is called as a thermocol plastination. Basically, in our home or in our labs, you get things, products or equipments that are supported by this supporting material, what we call as a thermocol, that is usually available. And often we throw this thermocol outside after taking the equipment or anything outside, anything out. So this thermocol basically is an environmental pollutant, and we throw it into the environment. That means we are adding something, some pollutant to the environment. So how to use this? Why cannot we use this so that we can basically in one way reduce one of the environmental pollutant from the environment, or use in the anatomy in a different way? So here, what the Department of Anatomy has basically one project that is sponsored by JKDST, and it is on this how to use this thermocol in the biological samples, in preserving the biological samples. So what we have done here is that we have collected the different organs. You can see this is a heart of dog, this is a heart of poultry, then this way it is a gizzard, then You can see there are so many organs here. This is a liver of poultry, then here it is a brain of sheep. So these are actual organs. They are not in the formalin, they are not in that epoxy resin, they are simply here and preserved by using this thermocol. How we use this thermocol? So what you have to do, you have to get the organs here first, then you have to wash these organs, you have to get this thermocol, and you have to dissolve this thermocol in one chemical that is here. So this in front of me, you can see this transparent chemical. This is a xylene, and this xylene basically any organic solvent will dissolve this thermocol. But here in the labs we have the xylene here. We have the used xylene basically here, and we can use this used xylene. And then what is left is if we just see here, if you see here that this thermocol, if I'm putting here in the xylene, you can see it gets dissolved. So it gets dissolved, completely dissolved. This thermocol gets dissolved. And what we have tried here, the percentage of the xylene, we have just 15 grams per 100 ml of xylene. We have to make this, and a solution will be made. So 15%, 12 to 15% of the solution we will make here. Then we'll keep it aside. So after just making this, we'll just close this. And there is some process by which a tissue goes. So there is some process by which the tissue goes. This tissue first we have to put into the acetone at minus 20, and then after minus 20 for 4 5 or even for 1 week, then we can just put this organ into this solution what we have made. So here in this bottle, if you look out, this is basically the thermocol solution that we have made by to adding xylene in this thermocol thing. And here if I'm going to open this, you can see that already one organ or one fish we have put it here. So this is a fish, this is a golden fish. So this fish basically, rather than preserving in the formalin or in that costly epoxy resin, this thing we will put here for more than 1 week. Then we can take it out and we can dry it, and we can dry it, and we can just keep it on any shelf or table without preserving them. So by this way you can preserve the organs by using the thermocol. That means you are using the thermocol and you are just removing one of the pollutant from the environment. And this organ you can touch, you can take anywhere in your pocket and show to the students. So these are the actual organs by they have been produced by this technique what we call as ecoplastination. So the thing is that the leftover of the this thermocol solution, because there will be some of the leftover of the organs we have taken out, there will be the leftover. So the leftover we can use it so as a binding material. See, in my hand there is a piece of a tile or piece of a cementing material here. So what I have added, I have taken some part of sand, some part of cement, and I have added this leftover thermocol solution to this. You can see it, tile like structure it has made. That means you can add this thermocol solution for the construction purpose also. And even the tiles, we have one more tile is here. So you can use this technique for preserving the organs. So in a way you can just remove one of the pollutant and preserve the organs rather than preserving the thermocol or in this costly epoxy resin. So ecoplastinates, let's support this and do the things those are environmental friendly. Thank you.